here we're talking about the median voter theorem. So the game is basically we have the political spectrum from say 0 and 1, and then the voters are distributed according to some distribution, say f of x, and then we have the mode is the maximum one here, and the median is where half of the distribution is on the left, half is on the right, say like this, half is on the left and the other half is on the right. So that would be the median. So if you look at this distribution, it's asymmetric, so half may be somewhere here. And you also have the mean. Mean is just the average, so the probability multiplied by the so the fraction multiplied by the number and sum it up. So say the mean could be here. And the question here is we have two politicians and they want to pick a position that maximizes the number of votes. So let's draw another new one with the same distribution. Say this is 0 and 1. So suppose one politician stands here, then and the other politician stands here, then they will the first politician, suppose this is the midpoint between x1 and x2, then the first politician will get every voter who is closer to the position of that politician. Then x1 will get all of these votes and x2 will get all of these votes. So it's not clear which one is larger. However, what we know is x2 can actually switch to here. If x2 switch to here, then they will share like this. So x1 will only get these people and x2 will get all of these people. So x2 will always have the incentive to switch to somewhere close to x1. So that will be the intuition. So the problem is, where would that stop? Because if you draw it the other way, say x1 is here, then x2 does not want to be here because x2 will get only a little. x2 wants to be on the other side now. So x2 wants to be here and get all of these votes. So it seems a natural guess is the median here, because half of the voter will be closer to the half of the people will be on the left of the median, and the other half will be on the right. So let's actually check that. So let's draw the same thing again and say our median is here. So if x1 is on the left of the median, then if I'm very close to x1, I mean if x2 is very close to x1, x2 can get all of these, and I know the median is here, so I know I'll get more than half. So that means I will win. So that means it's good. So basically on the left of the median, x2 wants to be very close but on the right of x1. And similarly, if x1 is on this side, x2 wants to be very close to x1 but a bit on the left. So like that to get more than half of the votes. So that leaves only one possibility. Oh, so know that these situations we wouldn't hold, because then x1 wants to switch. So for example, x1 starts here, and x2 will be a little bit to the left. Then x1 wants to switch to a little bit on the left of x2, and then they'll keep doing this. So these are always unstable, so they will not be natural equilibrium. So the only possible stable situation is both of them pick the median. So let's actually see if that's the case. So if x1 is here, let's see what x2 can do. So if x2 is slightly on the left, then they will share, and x2 will get a little bit less than half the votes. So x2 does not want that. And if x2 is slightly on the right, then for the same reason, x2 will get slightly less than a half of the votes again. So x2 must be standing right on top of x1, so they need to be at the same position, and in that case they will both get half of the votes, because if they they are in the same position, there will be a tie, then everyone will be equal distance to x1 and x2. So everyone will pick randomly. So that's why x1 will get half of the votes, and x2 will also get half of the votes. So the best response, basically the way to write this down, is the best response of the first politician given the second politician is picking the median. Let's say this median is m, would also be the median, and x x the best response of player two, politician two, given x1 is playing m is also m. So it's a mutual best response. So both of them picking m will be a Nash equilibrium.